This is Mr. Potter. In our previous lessons, we've talked about how we can use arrays to store large amounts of data. And we've talked in our previous lesson about how we can actually search through that array to find a particular piece of data. But one of the issues that we discussed was that if the data is not in any particular order, it's rather tedious to find something. And so what we're going to talk about today is we're going to talk about how to actually sort our data, how to get our data into a particular order. So I've got a class set up here, and what I'm going to do is I'm just going to create an int array, which I'm going to call nums, and I'm just going to have it equal to a set of numbers. So 5, 9, 4, 8, 3, 7, 2, 6, and 1. So just an array of numbers from 1 through 9, just in some order here. Not in a particular order, just because I want to actually put it in order. And what I'm going to do is I'm going to write a couple of helper methods here. And the first method I'm going to want, something that's really important when we're talking about sorting, is the concept of a swap. And what I'm going to want to do is I'm going to want to swap between two of these indices. So between an A and a B. But I'm going to definitely want to swap them within a list. And so I need to actually pass that list as a parameter. So I'm just going to say int array some generic list. It doesn't have to be my nums. It could be any particular list. Now, I want this to be a private method because only my class should be able to use this method. And because I want to call it from main, which is a static method, it also needs to be a static method. And the act of sorting shouldn't give me any data back. It should just change the list. So this is going to be a void type method. So I've got private static void swap. And it's going to be given a list and two parameters, something to swap from and something to swap to. So we'll just call that from and to, just to kind of give an idea of what's going on here. So the act of swapping means that I want to take something out of the array and put it in a second spot, but I also want to take that element from the second spot and put it in the first spot. And something like this, where I just say list sub from gets list sub to, and then list sub to gets list sub from. This actually is problematic because what happens is if I have an array that has a 5 and a 9 and I want to swap them, I'm going to move the 9 over here, so now I have 9, 9, and I've lost the 5 completely. So what I have to do when I want to swap is I actually need to have some type of temporary storage and have lists of from actually be stored there. Have the 5 stored safely away. So when I move the 9 over, I can take that 5 and put it in the spot. So this is actually going to be temp. And the act of knowing how to swap two variables so that they trade places without losing the data is an essential part of knowing how to program. So I've got this swap method here. The next thing that I want to do is I want to come up with an idea of how to print an array very easily. So again, this is going to be a private method, and I'm going to want my main method to call it, so it's going to be static. And printing is a task. Printing is not really something that's going to give me a value out of it. So I want this to be a void method, print. And I'm going to be given some int array, which I'll call list. Now, in our previous lesson, we talked a little bit about the dangers of using a loop to print out our data. So I'm doing int I gets 0, I gets list.length I plus plus, and we talked about how if I do system.out.print list sub I plus a comma, what this ends up doing is it ends up printing a comma after my last data value. And we talked about how to deal with this fence post problem. The idea was that we stop one short in our length, and then we use a system.out.println statement to print out what's in box list.length minus 1. And so this takes care of the fence post problem for us. So I've just got two private helper methods that are going to help me run this. And I'm going to go ahead and test this out. So I'm going to call on print nums. I'm going to pass nums. Nums is going to take the place of my list when I run this. Some little mistakes here, like I don't know how to put semicolons on. And what else? Semicolon here as well. And says error parentheses expected. What did I forget there? Oh, int list comma, because of my parameter list I need commas to separate my parameters. So that should take care of it. so this is just going to print my list. So 594837261. So that prints my list out in order. So my print nums work. So what I want to talk about today is I want to talk about two techniques for sorting. And I've got this wonderful program called Jelliet, which I'm going to be using to display how we're sorting things. So we'll talk a little bit more about that in a few minutes. But what I want to do is I want to sort, and probably the easiest way to sort would just be to set up some procedure where I compare two elements, like compare the 5 and 9. And if they're in the right order, then I leave them there. Then I look at the next two elements, like 9 and 4. And they're not in the right order. So I need to swap them. So if I swap them, my list will look like 5, 4, 9. And I can do that going all the way down the list. And if I do that a certain number of times, then my list will be completed. This 5, 4 that I do after the swap, I swap again, and that becomes 4, 5. And eventually this one will swap here, and then it'll swap here, and it'll swap here, and then here, and here. This one will kind of bubble up to the top of my list. My smallest value will make its way towards the top of my list. And so this technique is actually called a bubble sort. And so I'm going to create a bubble sort method, which is going to be given a list. And of course, this is going to be a private helper method. It's going to be static because I'm going to call it from my main. And it's a task, so this is going to be void. So this is my bubble sort. So the first thing I'm going to do is I'm going to start by doing a loop. So I'm going to do for int pass gets 0, pass is less than list.length, pass plus plus. Because my list illustrates one of the issues is that if I want to get this 1 all the way to the front, and I'm only allowed to swap once per pass, it's going to take 1, 2, 3, 4, 5, 6, 7, 8 passes. It's going to take basically every time I go through the list, it's going to swap once. So I want to go through the list as many times as I have objects in my list. So this is basically just a counter that's going to go through and make sure I go through the list a certain number of times. This actually takes care of the swap. So I'm going to do int spot gets 0, spot is less than list.length minus 1. And I'll talk about why that is in just a moment. Spot plus plus. The thing is, if I want to compare 5 with 9, I'm really comparing spot with spot plus 1. I'm comparing spot with spot plus 1. But as I get near the end of the list, spot and spot plus 1, this spot plus 1 starts getting treacherously close to leaving my list and giving me an index out of bounds exception. Spot and spot plus 1 would do that. So I'm going to stop short right here. So I'm going to stop at list.length minus 1 space before the end of the loop. And what I'm going to do is I'm going to ask if the list at spot is greater than the list at spot plus 1. If that's true, in other words, if this 9 is bigger than the 4, or if this 8 is bigger than the 3, then they're in the wrong order and I need to swap them. So I'm going to call upon my swap helper method, passing it my list, passing it the first number, which is spot, and passing it the second number, which is spot plus 1. And that's really all that I need for this. So this is my bubble sort method. And what I can do is I can actually call upon this in my main. So I can do bubble on nums, and then I can print it again. And so if I do that, I'm going to run this. And notice what happens. It had my original list the way I had it. And after it went through the loop, my list is nice and sorted in a nice, picturesque order. So what I'm going to do is I'm going to take all of this code that I've got, and I'm going to copy it, and I'm going to paste it in this application. Now, this application, if you go to cs.jeliet-webstart.php, I'm going to put the link in the description. You're going to click Start Jeliet, and this will start if you have Java installed. And what this does is this allows us to get a picture representation of what's going on here. It's not just a program compiler, but it also gives a graphical representation of what's going on. So it's actual theater. And notice the curtains part. And what's going to happen is that it's going to step by step go through my list. So here's assigning my list, and it's going through starting at 0, and it's looking at the 5 and the 9. Actually, right now what it's doing first is it's printing out the data. So it's printing out the 5 and the 9, and then it'll print out the 4. So it's going to go through that. It's going to take a while to do it because it's showing all of these logical tests as we go. So what I'm going to do real quick is just comment out these print statements because we can see what's going on. So we'll compile again and we'll play it. It's going to print our array. It initializes it. And now we're going to go through here. It's going through our spots and it's checking. If that spot is bigger than that spot, then it's in the right order. So 5 is greater than 9? No. But 9 is greater than 4. So what we need to do is swap. And notice the 9 and the 4 gets swapped. Then it's going to compare the 9 and the 8. And they're also not in the correct order. So the 9 and the 8 will swap. And so this goes through step by step, showing us where we have the swaps. Notice that instead of really our 1 bubbling up to the top, which it will eventually, as I go through this pass, the 9 is constantly being swapped down. So eventually the 9 will kind of settle down to the bottom. Really should call this a sediment sort instead of a bubble sort. But this jelly is a real good way of picturing what's happening inside of this list. Now, one other thing that I could have done, after I go through one complete pass, this 9 is in the right spot. This 9, notice how it's getting slowly going to the bottom. Here's one more swap. We're going to have one last swap before the 9 reaches its final resting place. Technically, I could stop the loop short and make sure I never look at that 9 again because it's in the right spot. The way that I've programmed it, I'm going to constantly be looking at it, and that's fine. But if I want a program that runs more efficiently, say if I had 10,000 numbers, then this is going to take a long time. And so it's just something to be aware of. There are better sorts out there. So I'm going to go ahead and stop this because I think we've got a good picture of what's going on here. We can see the numbers rising, smaller numbers are rising up, like here this 3 and this 8 are swapping. The larger numbers are settling down towards the bottom. So I want to go back to our program here. I've got our bubble sort, and that bubble sort works, but it's not necessarily the most effective way of sorting this. So I want to look at this data again. What would be really nice is if I went through this list and said, oh, 1, you're the smallest number in this list. How about the 1 and the 5, you two trade places? And then I go through from this point on. I say, okay, for this part of the list, 2, you're the smallest number. 2, you and 9 trade places. And then I go through this part of the list and I say, oh, 3, you're the smallest. 3 and 4, you trade places. This idea that I could select what the smallest number is and select the next smallest number and put it in order that way, that seems like it would be much more effective. Like I wouldn't have to go through as many passes. And there is a technique called selection sort, which we're going to talk about. That's going to be our last sort for today's video. So, I'm going to do another private, static, void, and I'm going to call this selection with an int array list. And the idea behind the selection sort is this. I want to keep track of where the minimum position that I've seen, the smallest number in my list. So I'm going to keep track of that in a variable, which I'm going to call min. And I'm going to assume at the very beginning that min is my first position. And then what I'm going to go through is I'm going to go through my list. So let me put a semicolon on that line. That would be helpful. So now I'm going to go through. So for int pass gets gets 0, pass is less than list dot length pass plus plus. And then I want to go through and start looking at stuff. So I want min to be equal to the pass. Keep in mind that after I've put the first number in position, now I'm in position 2. I'm going to assume 9 is the smallest number until I find something smaller than that. And then I'm going to do another loop. I'm going to go through and check each spot. So spot gets pass, spot is less than list length, spot plus plus, and if what's in list at spot is less than what's in list at min, then that's my new lowest. That's my newest smallest value. So min is going to get spot. And then once I've done that, once I've gone through this list a certain number of times, then I want to swap. And I'm going to swap in my list whatever is in the pass position with min. Now, let me kind of illustrate what's happening here with the list that I have up here. Right now, I'm assuming that 5 is the smallest number in my list, and I keep searching. Oh, 4. You're smaller than 5. Maybe you're the smallest number in my list. Then I keep going, oh, 3, maybe you're the smallest number in my list. And then I keep going, oh, 2, and then, no, definitely 1. So the 1 is my min, but 5 is still the pass, because I'm still looking at that first position. And so I end up swapping the 1 and the 5. And now pass is in this next position. It's in position 1. So now I look at this and I go, here's a 9. Oh, 4 is smaller than that. 3 is smaller than that. 2 is smaller than that. So now this is my min position, and it's going to swap with pass. And now I have a 1 and a 2. The first 2 numbers are in the right order. So I want to run this real quick just to make sure it runs. Now, of course, it's still doing bubble sort, so I need to fix that. This is supposed to be selection sort. And notice that it also puts my list in order. So what I'm going to do is I'm going to copy this selection sort and I'm going to paste it into my Jellyet as well. Let's go back to edit. And so after this method, I'm going to paste my selection sort. And I'm going to change bubble sort to selection sort. And I'm going to compile. Now again, it's going to start off the same way, where it's going to populate this array. I'm going to see my array fill up. And then it's going to keep track of the minimum position and this pass position. So notice that pass stays 0. But I'm going through and seeing which one of these is my smallest. Found something that's smaller. 4 is less than 5, so now 4 is where my minimum is. Now I'm continuing to search. I'm looking for something smaller. 3 is smaller than 4. That's now my minimum in position 4. And I keep going until I hit this last position, which is the smallest number on my list. So once the smallest number on my list, it's in position 8. So as soon as min gets to be 8, we're out of the loop, and now we're swapping the 5 and the 1 trade places. And now this is my smallest position, so I don't look there anymore. I'm going to be changing pass, which is where this 9 is, with something else that's smaller. By the way, notice the 4 was smaller, and now it's going to say the 3 is smaller. So what I'm going to do is I'm going to let this run just for a few minutes. I'm not going to say anything, but I want you to look at the numbers. Watch how the position of the minimum changes as we go through the list. Okay, so now we're looking for something that's smaller than 4. It's going to keep searching until it hits this 3. So when I see spot is 4, it's going to compare. Notice 3 is less than 4, so now that's my new minimum. And none of these other numbers will be able to compare. Nothing beyond this 3 is smaller than 3. And so this is never going to change past 4. I'm going to go all the way to the end of my list. And then I'm going to say, wait a minute. So I swap them. The 4 and the 3 trade places. And now I'm looking for my next smallest number. Notice, by the way, I've gone through the list 3 times, and the first 3 numbers are already in order. And that's what's nice both about the bubble sort and the selection sort, that after every pass, one number is guaranteed to be in the right spot. After 2 passes, 2 numbers are guaranteed to be the right spot. The only question is, are the numbers guaranteed to be in the right spot in the front of the list, where the lower numbers are, or at the back of the list, where the larger numbers are? With bubble sort, the larger numbers settle to the ground as the smaller numbers bubble up the list. For insertion sort, for selection sort, we're physically finding the smallest number and jamming it into the right spot. Then we find the next smallest number and jam it into the right spot. Now there are lots of different ways to represent this. I could have done this on a sheet of paper, or I could have done this with an electronic chalkboard. I'm doing it with this Jelly application. Notice my list is almost completely sorted. I just need to get this 6 in the right spot. But if you want to find something that really kind of demonstrates this, really brings it out, I do suggest that you go to YouTube. And I suggest that you look for Hungarian sort, Hungarian sort dance. And these sort dances are going to be a lot of fun to watch. So we can see this selection sort danced out in front of us. We can see them actually picking out the smallest and putting it in the right spot. Or we can see the bubble dance. We can see them bubbling down towards the end. I suggest you take a look at all these different dances, because there are lots of techniques to sorting. And we're going to get into more of those later on this week. So once again, this is Mr. Potter. Thank you for watching. Have a great day.